Lesson 7.1, Angles of Polygons. If you remember from a long time ago, a polygon is a closed figure made of straight segments. A diagonal of a polygon is a segment that joins non-consecutive vertices. So here's a polygon, and notice it has these straight segments. The diagonals connect non-consecutive. Non-consecutive means not next to each other. So like connecting B to D is non-consecutive because C is in between. And B to E would be non-consecutive because the A is in between. Diagonal would be segments that are not sides. Notice something about these diagonals. If I drew the diagonals from B, it divides this pentagon, because there's 5 sides, into some triangles. So all polygons can be separated into triangles by drawing the diagonals. So again, there's that one. Now let's try another one. Here's a quadrilateral. If I draw all the diagonals from that point, I get a couple triangles. Oh, hey, let's make a chart. Sides and triangles. If I have 4 sides, I get 2 triangles. The one that's already there, I have 5 sides, I get 3 triangles. Let's draw 6 sides. There's all the diagonals from one vertex. There's 1, 2, 3, 4 triangles. Let's do 8 sides. Draw all the diagonals from one vertex. If I have 8 sides, I have 1, 2, 3, 4, 5, 6 triangles. So since it's divided into triangles, how many degrees are in the triangle if you add up the angles? 180. So I know the sum of each triangle. To get the sum of all of them, then all I have to do is multiply by the number of triangles. For the pentagon, that was 3. In general, it looks like there are 2 less triangles than number of sides. So to find the sum of the interior angles, it's just 180 times the number of triangles, and the number of triangles would be the number of sides minus 2. Which is the polygon interior angles theorem. The sum of the measures of the interior angles of an n-gon is n minus 2 times 180. N being the number of sides. And to be more exact, this is for convex polygons. Let's look at the specific case for a quadrilateral, since that's what this unit is about. It's quadrilateral. N would be 4. 4 minus 2 is 2 times 180 is 360. So the sum of the measures, the interior angles of a quadrilateral is 360. This coin, the dollar coin from Canada, called a loonie because it has a picture of a loon on it, is a regular 11-gon. Find the sum of the measures of the interior angles. All right. So we would have the sum equals n minus 2 times 180. N is 11 because it's an 11-gon. 11 minus 2 is 9. And 9 times 180 is 1,620. So that's if you take this angle plus that angle plus that angle plus that one plus that one plus that one. You add up all the angles all the way around, you get 1,620 degrees. What if you go the other way? I'm telling you the sum is 1,440 degrees. What type of polygon is it? Well, we can still use the same formula since I know the sum of the angles, and that would tell me the number of sides. So the sum is 1,440. Could solve for n now, so let's divide by the 180, which gives us 8. And then add the 2, and we get n is 10. So there are 10 sides. 10 sides is that's right, a decagon. Find measure of angle T in this diagram. Well, we have a pentagon here, and it says T and S are the same angle. They're congruent because they each have the same number of arcs. So what I could do is I could find the sum and use the formula. So the sum is simply adding together all the angles. N is 5 because it's a pentagon, 5 sides. And then on the other side, 5 minus 2 is 3, times 180 is 540. Subtract the 334. You get 206. Divide by 2, you get 103. So measure of angle T and measure of angle S are both 103 degrees. Few definitions. Equilateral polygons. Equilateral means all the sides are congruent. Equa means equal. Lateral means sides. So equal sides. Equiangular means all the angles are congruent. Now I would like to point out that just because it's equilateral does not mean it's equiangular. This angle and this angle are not the same size, even though it's equilateral. And if it's equiangular, it's not equilateral. Those are different length sides. So just because it's one doesn't mean it's the other. However, if it is both equilateral and equiangular, so all the sides are congruent and all the angles are congruent, then we say the polygon is regular. Right, those were interior angles. Now for exterior angles. The formula is much simpler. The sum of the measures of the exterior angles of a convex polygon is 360 degrees. No formula, they're always 360. So here's a pentagon with the exterior angles drawn. Remember, to get the exterior angles, you extend the side, and it's the angle between that extension and the closest side of the polygon. Now, is this pentagon actually regular? No, but let's pretend it is. The sides are different lengths, the angles are different measures. If it was regular, the picture would be exactly all the sides exactly the same length and all the angles being exactly the same size. But anyway, If all 5 angles add up to 360, you could think of it as something like that, where all the angles are the same measure because it's regular. We'd have 5x equals 360, or each one would be 360 divided by 5. Which is 72. Or if you'd like, all the angles are 360, divide that by 5, gives you one angle of 72. How about the measure of one interior angle of a regular polygon? Well, you could look and say, well, the exterior angle and the interior angle make a linear pair. And linear pairs are supplementary. So we could say the interior plus the exterior angle have to equal 180. Well, we already learned that the exterior angle was 72. So that means the interior angle must be 180 minus 72, or 108. Or you could use the interior sum theorem. N is 5 because it is a pentagon. So the sum is 540. But again, that's all the angles added together, but they're all the same. So it's like saying 5x or 5y. I'm using y because I already used x for the exterior. Divide that by 5 and you get 108. So for a regular pentagon, the interior angle is 108. The exterior angle is 72.